All right, let's get started. Uh, Little introduction about me. I'm VijayMisra. I'm working for IBM as a senior manager in Data Group. Uh, it's a product based for enterprise data needs. Um, and before I start, I just want to say thanks to Dr. Tasneem and Dr. Farooq for inviting me and making me part of this seminar. Um, yeah, so let me share my screen here. All right, so today's topic is exploring the data lakehouse evolution. So before I go into the data lakehouse and talk about here are my three objectives. So first one is, explain what a lakehouse is and how it differs from the data warehouse. And the second one is discuss the benefits of a data lakehouse in terms of how we can scale the data and how can we be more resilient in terms of data needs. And third objective is the provide real world examples of enterprises or companies who are using data lakehouse. So the very first thing comes up what a data lakehouse is. So it's a data architecture. Before a data lakehouse, they used to have the data warehouse, data lake, those kind of things. But now with the advent of new technologies and the cloud and all, data lakehouse is the new architecture. So data lakehouse is a modern data architecture that combines the feature of a data lake and the data warehouse. So basically, both of these paradigms of data architecture, they have their own benefits. So, but each one of have their limitations as well. So if you can combine both of them, then it becomes the data lake house, data lake plus data warehouse. So we took one term from each. What is data lake? Data lake is actually you can dump all of the enterprise data into any storage. Um, it could be raw data and unstructured data and the semi-structured data or completely unstructured like images and video files. There could be some XML and JSON files which is semi-structured. And then you report or create reports and the business intelligence on top of that kind of data. So here comes the data lake, and now the data warehouse is where you have the structured data in form of table like RDBMS. You do all the analytics on the relational table. So these were the two paradigm used before, and but the question comes why do we need this data architecture? We'll talk about that. And before that, I need to tell what is the today's problem and how every enterprise needs to have a solution for these kind of problem. First of all, there's more data. Data is increasing every day. Like every uh, organization, we have more images, more videos thanks to mobile phone. We all take photos, pictures, videos. So there would be 250% growth of data in the next 5 years. That's the kind of new study. And data actually is stored in the multiple locations. So there could be multiple copies of the data. It could be on the cloud, it could be in your on-premise data center, or it could be several locations basically. So 82% of companies have they are inhibited by data silos. So data silo is completely different problem. Like you can have data only at one place, and there's no mechanism to to access that data. All of people have to connect to that data silo, so it's kind of very difficult problem if you have data silo, because you need data availability all the time, and if that data silo is not available, then you are kind of business discontinuity happens, and then you have to cater to or resolve that business discontinuity. So another problem is like data is in the complex forms. It could be document, it could be images, videos, and more. Like 80% of time people spend or enterprises spend in data cleaning, integration, and preparation because they are the different kind of data. And the fourth one is the poor quality. If you have the data mm, available in the different geographies, that there are chances that your data is not synced, or one site has a more relevant data or more recent data than as compared to other. So this is one of the problem because if data is not synced, then one or other way you lose the value of the data. So poor quality of data is one of the problem. But uh, I think the first point is why you need a data architecture, right? So I think the very first thing any businesses or any business face is that they have to answer some of the questions, right? But the biggest problem is how to ask the right kind of questions. So for that, you need a data platform. Data platform in the sense that where you can store all the data, and when you need, since it has all the data, you can ask, for example, like how much sales it would be for my company, for how much revenue I would be generating. So those kind of things. So I think for answering those questions, you need the data platform. But in any like in the business world, we do the commercial building. How do we make commercial building? You need a good architecture, good template, good kind of blueprint for that building. The similar thing is here in the data architecture. You need to have good design, and the very first two things which comes to kind of um, data platform comes to it is the data ingestion, and that you should be ingest the data. And second thing is how do you store the data? So data storage is, and so data ingestion and data storage are two primary things. So to implement such data platform, one needs a robust data architecture, one that can help you define the core components of data platform and establish the design principles for putting it into the practice. So traditionally, organizations have used data lakes and data warehouse to implement their data platforms. But Lakehouse is actually, it's the architecture is one such modern architecture pattern that has developed in last few years and has become a popular choice for the data architects who are designing such data platforms. Little bit of history about how it has evolved. So if we talk about late 1990s, uh, it started with a data warehouse. Large organizations, they used to store data in their big costly data warehouses, and they used to run all sorts of dashboards and business reports on that data warehouse. So, but you have to spend money. You have to high upfront cost was there, but it was only available for the structured data. And before you put any data to data warehouse, and it is ready for your queries, you do need to do ETLs. That is extract, transform, and load process. So ETL was required, and there was one more problem. There's a vendor locking, right? You buy it from organization ABC, this data warehouse, and you are locked in kind of to that data warehouse because they have their own proprietary engine, they have their own data format. So there was a very less of a movement from one enterprise server data warehouse to another data warehouse. So there was very less movement. So that was the problem with the data warehouse initially. Then early 2000, there came a concept of data lake. So data lake is nothing but it's a platform where you can dump all the data, whether structured, unstructured, any form of data, and then you can run the dashboards and reports. With a data lake, actually, it was very cheap, and but the data quality was poor because you are dumping all the data and you cannot segregate what data is what. So that was the problem with the data lake. And then I think when the cloud came, then it came as a cloud data warehouse, and cloud providers they started providing the data warehouse in the cloud. So it actually started, solve some of the problems of you in the sense that you don't have to buy your own hardware and you can offload that capex expenses to the cloud provider. So cloud data warehouse came, and but again the problem was it was a warehouse, so you have the very limited machine learning and AI use cases for this kind of warehouse. Then lastly, it came the data lake house, which is the today's topic. So actually, it caters to the both BI and AI use cases, business intelligence and artificial intelligence. So BI, when we talk about BI, we talk about dashboards and reports, which runs on the relational data or some sort of structured data. AI could be run on any kind of data. So artificial data for that you need cheaper storage because with these days a lot of data is there, and if you cannot put all the data in the data warehouse because it's very costly, as well as you have proprietary engine, so you cannot have the data movability. So most enterprises today require two-tier architecture actually. So they have the data lake and data warehouse both, and they try to sync all the data, keep in sync all the data. But sometimes when the one schema changes in the data lake, then you worry about changing it into your data warehouse. So that's one of the issue with the syncing the data lake with the data warehouse. And data warehouse, of course, it has the proprietary engine and the data lake storage. Moving on, so let's talk about what is data warehouse and how it works. So the diagram I'm displaying here, it's a typical example where you have multiple sources, source system 1, 2, 3. It could be your any kind of data, and this is structured, and then structured data has to go through the ETL process, extract, transform, and load before, because you could have it's a raw data. There might be some empty fields, some there might be some null values, there might be some mistake by the human user, and while filling the data, and that data is not proper. Instead of string, you have the int. So that kind of problems in the data should be eliminated through the ETL process, and then we put it into the data warehouse storage, and then you can do all the reports and dashboards on this structured data. So here is the process depicting the data warehouse, how the reports and dashboards are created. And the second thing is data lake, where you have structured, unstructured, and semi-structured data. And you put it, like, kind of dump it into the data lake, and you can have reports and dashboards on those that kind of data, structured data. And if it is unstructured, then you can run the AI and ML workloads. So data lake, it does not have any ETL process in between, as we have seen in the data warehouse. So again, the cloud data lake comes. Cloud data lake, actually, it has AI ML workload. You can run on the cloud data lake, and then you can do the ELT and ETL process and put that data into the cloud data warehouse. So ETL and ELT, I think when it started, everything was ETL, because you extract the data from the source system, transform it, and then load it into the warehouse. with with the advent of compute and cheap storage, what happens, like you extract it from the source system, you load it immediately into your system, and then you transform it there, because now you have the compute available there itself. So that's the use case of cloud data lake and the cloud data warehouse. It could be within a same cloud service provider, and you can run the AI ML workloads on the cloud data lake, and reports and dashboard you can get it from transforming it into or moving it into the cloud data warehouse. So that's the use case of cloud data warehouse and cloud data lake. There are certain features like data lake provides, and there are certain feature data warehouse provides. So first of all, data lake is highly available. Like it is, it's cheap. Like example would be Amazon S3, ADLS, Azure Data Lake Storage, or GCS, Google Cloud Storage. So in all these storage, you can have the object storage. You can put any kind of data XLS file, doc file, or maybe the images and video files, and it would be highly durable. There we are talking about 5 nines or 11 nines of durability. It can have all kind of data, structured, semi-structured, and unstructured, and it is a very good use case for the AI and ML workloads. On the other hand, data warehouse have this kind of features where first of all, it has the ACET support, atomicity, uh, durability and atomicity, consistency, isolate, and durability. All ACID, properties of a relational database, better performance, because of course you are storing it in form of structured tables, and there's support for updates and deletes. There's a fine grain access control and support for SQL and support for BI workload. So all the dashboards and reports, they are pretty good example in the data warehouse use cases. You can generate through data warehouse. So BI use cases are very well catered through the data warehouse, and data lakehouse is very conducive for AI and ML. But the question comes, why we need this kind of uh, data architecture. So as we talk about data architecture, we need a robust architecture for any building, right? If we are making any building, then we need innovative design, we need experienced architect, we need army of construction workers. So similar thing is applicable to the data platform, where you should have a good architecture for your data platform. The data architecture helps you define the foundational activities that you need to do to start building your platform. So any data platform has certain components. They are bound to have those components for a robust data platform. So the very first thing is data ingestion. Like you should be able to ingest the data into the data platform. Then you should have the data storage and data transformation, and fourth thing is comes like how do you consume that data, and let me share this screen. So components of data platform, there are these components you're seeing on the screen. There could be source system, those are internal systems, and there could be structured, semi-structured, unstructured kind of data, like for example, your emails, your CRM system, your ERP system for any enterprise, and all images, videos. There's all three kinds of data in any organization, and there's another feature in terms of velocity, that it could be batch, it could be near real time, or it could be streaming. So batch data is something like, for example, you are generating the electrical utility bills for all the customers of your electricity company. So you'll give all the customers data, their usage data to Hadoop or any big data platform, and it would generate in the batches because it has all the data, all months data, and it will generate it in a batch. Near real-time system, they have kind of smaller data, or you can call it the micro batches. So it would not be, that much duration, but data would be coming through the system in a, let's say, 1 hour time period, or maybe sometimes it is 1 minute as well. So, and depending on the system. But that is called the near real-time system. Third one is the streaming data, where you cannot delay the data, and for example, the clickstream data, for example, customer or server logs, and the stock exchange data. So every second, every millisecond, it is changing, and if you miss that data, then you miss the value of that data. So I think uh, that is very, very important in the streaming kind of data. So whether it's internal system or whether it's external system could be, you, for example, you need currency conversion rates, so you need to have the external data from outside from your organization. So that is a one example of external system. All this data, whether it's a batch, near real time, or streaming, all you have to ingest in your data platform first. And then after ingesting, you have the data processing and the transformation. What data transformation is actually that you sometimes data is raw, sometimes fields are not correct, sometimes fields are null, and sometimes they're duplicated values. So you need to make it, good data before saving it into the actual data storage. So data validation comes into the picture, and data validation and cleansing needs to be done on that data. Data transformation is like, you have the same data, but you have the, for example, I'll give one example where you have the different part of the words have the different date formats like DDMMY and MMDDY. So you want to save it in a correct format and in one format. Correct is not the correct term, but yeah, so you want to save it in the one format, which you can always say that, okay, data is stored in this format, and use it everywhere in a uniform way. And sometimes data curation and serving is required. Curation in the sense that you want to divide the data in the product IDs, or you want to divide it in for a certain months time period. So this activity also comes under the data processing and transformation. And then there comes the data storage part. Data storage is like when you ingest the data, how would you store the data? So it could be normal S3 storage, or it could be any purpose-built storage. So I took the example before. I give the example before that it could be S3, or it could be ADLS, or any other Google Cloud storage. You save it in the object format, and any object could be stored. Any data object could be stored in the general storage. Purpose-built storage are certain, specific purpose. For example, if you have RDBMS, RDBMS, relational database, so that is called the OLTP workload, because you have online transaction processing, and you save the data in the table format. And but if you have to do any analytics on top of this kind of relational table, then you should have the data warehouse, that is called the OLAP workloads, online analytical processing. And normally industry practice is that you don't want to do analytics on your production data or production RDBMS, because the reason is it would your customer serving queries or customer serving process. So normally people put data warehouse and RDBMS separately. And one other example of purpose-built storage, it could be in-memory database. Uh, in-memory database for the faster data retrieval. Sometimes you need data very fast, so you have the one kind of purpose-built in memory database. And then there's another variety graph database where you have the store, you have to store the connections and the relations. Like for example, if we take the example of LinkedIn, who is connected to what, the people's are kind of nodes, and their connection, whom to whom they are connected is actually kind of relation. And the same thing is with the social networking, or also, the Facebook and other. So if for that kind of storage, you need purpose-built storage. Okay, all right. So, and apart from these, data processing and transformation component, there are some common services like metadata management. So what is metadata? Metadata is data about data. Like you store information about tables, what columns they have, and so this sort of creates a faster query system, because when you do query, you have the data. You don't necessarily need to go to that table, and you query this metadata for the faster response. So metadata management is one of the like people use Hive data management or HMS, Hive Metastore for this purpose. And the second component of the common services is data governance and security. So data governance is a kind of policy on rules or standards that ensures that all data processes follow the same formal guidelines. So these guidelines helps to ensure data is trustworthy, it's high quality data, and delivers some value to the enterprise and organization. And secure, of course, data security is a part of data platform, that your data is secure, and it cannot be easily accessible, and there are some permissions and rules around that data. So that should be inbuilt thing into any data platform. And data operations is where you can move the data from your data platform to other databases, or other kind of data systems, and a lot of operations could be performed. So that all comes into the data operation. So these are overall kind of components. I'm explaining that in any data platform you should have these components. The last part, which I have not covered, is the data consumption and delivery, which is very important part, because that's the very reason that we are creating this data platform. So there are four use cases: data consumption and delivery, like business intelligence, that you should be able to create the reports and dashboards and other things. Second thing is like there are certain meetings where people ask how much revenue would be in the next quarter, or um, how much we would be generating the revenue. So those kind of things uh, can be answered by the ad hoc queries. So you should have the interactive query system also, um, the data platform. And other thing is downstream applications, or the API. They call those application, those APIs, and you should be able to get your answer. So basically, it's a REST kind of API, where you just call this API, and this would complete your query and whatever operation you want to perform. And last is AI and ML use case, where you have your models and everything is running, and you just provide this data, and they predict, they do a lot of recommendation, and they provide those values, forecasting and recommendations through the models. So the question comes, why do we need a new data architecture like Lakehouse? You know, so data warehouses and data lakes have remained the most popular architecture for implementing data platform. But there's new approach. Why? Because it's a traditional architecture have several limitations. There have been multiple technological advancement also in last few years, or innovations within cloud space, and the maturity of open source technologies. So some of these new architecture, or the new innovations, like people started using two-tier architecture, combining a data lake, and data warehouse to support BI analytics and AI, artificial intelligence, both on the same platform. They leverage hybrid transactional kind of processing in one platform that is called the HTAP technologies. And the third thing people tried building modern cloud data warehouse that can process unstructured data along with the structured and semi-structured data. So these are the people have tried these kind of things to overcome the limitations of data warehouse and data lakes. So all of these efforts indicated a need for a new architectural patterns that can support the implementation of a new simple unified platform that can handle all data formats and a diverse set of use cases to help users easily consume data, right? Diverse case means like you should be catered to business intelligence use cases. You should be able to do the ad hoc query. You should be able to support all your applications. Now we are in the age of apps. So apps should be able to call your APIs pretty quickly. And there was a need for a ACID support, again like RDBMS ACID support for the excellent BI performance and access control mechanism of a data warehouse, which was not possible in the data lake, because you are dumping all the data and you need some sort of structure in the data to before you run a query on, right? So you needed one unified data platform where you can put all the data and you run all your queries. It's like data warehouse kind of capability on your data lakes, right? So and the third thing is the provide the scalability and the cost efficiency and the flexibility of the data lake. So so I think I should move forward and tell what actually is the architecture of a lake house. Sorry. So Lakehouse is nothing but it's a combination of your storage layer and your compute layer. And storage layer has a cloud storage, as I was talking about. You dump all your data, and then but the normal question people ask, if you're dumping all the data, then how would you query the data? And it's a different kind of files, structured, unstructured. So somebody needs to create some kind of structure before you do query. So for that, we use the open file format. And open file format could be, your, any Parquet or ORC, or yeah, there are different kinds of open file. Open in the sense that that is open source. Anybody can have, that those kind of file format, and they can use it in their enterprises. So that's the one big move from the proprietary software, because you don't have to buy their companies big storage and engine and the proprietary engine that can only work with one type of format, not with others. So I think open file format came, and that's why the Lakehouse is an open data platform where you're not locked in with any specific vendor. You just have to have your own object storage and open file format. And then there's an additional transactional layer on top of that, that is open table format. So I think there are three main open table format. One is Apache Hudi, second is Apache Iceberg, and third one is by a company called Databricks, and they created their data lake, Delta Lake kind of proprietary platform. So to some part they have open source some of it, and they have some part is their commercial uses, but still there are three open table format, and they kind of provide additional transactional layer on your data storage. And Lakehouse compute layer is like number of you can have your processing engine, Example of processing engine could be, Presto, or it could be Presto, Trino, or there are some others. I think Spark, Presto, Trino, Hive, these kind of they are the example of open source engine which enterprises are using in creating their data platform. And there's some commercial engines also, like companies like Dreamio, Starburst, Databricks, Snowflake. They have their own engines, but you're not bound to. If you want to create your own lakehouse, you can do it. And you just need to have the object storage on any cloud provider, and you can use any of the open source Spark, Presto, or Trino engine. And so basically, so these two things comprise the lake house storage and lake house compute layer. So if we go into the granular architecture of a data lake house, we see it's all supports all kind of workloads. The first top is the business intelligence, and then ad hoc and interactive analysis, which is actually nothing but you should be able to run the query, and you should be able to downstream. You should be able to support the downstream applications and the API. Um, and the fourth use case is AI and ML, and the below layer should have any open source processing engine or commercial processing engine. Open source, I think I give the example. It could be Presto. It's a lot of companies are using, like Uber, Facebook, for their data queries and other things. So they are using this Presto and Trino for querying their systems, and they are running millions of queries in a day using these technologies. All right, so open table format, I give the example. Delta Lake is by Databricks, Apache Hudi, and all these are all open source. Apache Iceberg, it started from Netflix and provides ACID properties on your unstructured data, and it's pretty good in the sense that um, it's running on your data, unstructured data, and it provides certain sort of structure to so that you can run your query on. And open file format, Parquet, Avro, ORC, pretty popular format. So you just have you need to have these on top of your storage or your object storage, and then you can access a transactional layer. You put the table format, and then you should be able to run the query. So basically, this is the example of lake house in the more granular form. That below layer is the storage layer, and then you can run the queries through the compute layer using this open table format. So this Iceberg and Hudi and Delta Lake, they change the whole thing in the data query and the data processing framework by introducing this feature on top of unstructured data. Yeah, so actually, this is the same figure. Simple, you just to emphasize that you could have open source processing engine, and you could have commercial also. It could be from Dreamio, Starburst, Databricks, or Snowflake, or it could be Spark, Presto, Trino, or Hive. Moving on, so if you see the data lake house, there are only two components. You separate storage and the separate compute. So and one of the big selling point, or what you call the big feature of the lake house, is that it has the single storage tier with dedicated warehouse kind of thing, the warehouse like performance on the data lake. How do you provide this performance? By using optimization lever and the storage and the compute layer. So there are certain settings you can do with with this table format and the file format, and they would give you warehouse like performance on top of data lake. And other thing is you have the decoupled architecture with a separate storage and the compute. So if you see the biggest, the advantage of this figure is that, or always architecture is that you can scale your storage independently of your, right side, your compute, right? So you can put more storage, you can put object storage, and on the other hand, you can have the different variants of Spark or Presto or Trino. So scaling, there's no limit, and both of these components can be scaled altogether in separately in a different way. Okay, moving on. Yeah, so cloud storage, it could be, so there's a similar thing. Actually, I was telling just a layer by layer approach. So cloud storage, it could be S3, AWS or GCS, Amazon, and Azure Data Lake Storage and Google Cloud Storage, and then coupled with the open file format, open table format, and then this is your storage part. Second layer, you could have, a file format. You could have Parquet, Avro, or ORC, and these are all open table for open file format, and then open table format, right? So basically, these three things, these three are the popular variant of any table format, and they gives ACID properties, a lot of other properties, schema evolution, and schema restriction. Those all kind of things are pretty cool features in the open table format, where you can give structure to your raw data, and do the query on top of that. So I think we are near the end of this talk. So I just want to give you the benefits of Lakehouse. So the very first thing is that no additional efforts are required to sync data between data lake and data warehouse. Because if you traditionally, people used to uh, s- both the kind of architectures, and they are always bothered about whether their data is in sync or not. So since Lakehouse is a unified data architecture, because you are storing data only in one object storage, there's only single one object storage, right? There's no data lake, there's no data warehouse, and but you provide data warehouse kind of a thing on top of data lake. So you don't need to worry about changing the data formats. The second advantage is the data governance. Data governance, like compliance. There are certain compliance rules you have to follow, and data governance becomes much easier in Lakehouse, as you have to apply access controls at only one place, not at the data lake and the data warehouse, because you have the storage at one place, so you have the data governance at only one place. And ML workloads also can read data from the Lakehouse directly, accessing underlying, Parquet, Avro, or ORC storage files. So this actually removes the need to copy any aggregated data from the warehouse to the lake if required by the ML workloads. So you can do the ML workloads, AI and BI, as I always say, that it supports both. So Lakehouse is the upcoming architecture, and people are using it. It's an open format, and you are not, you don't feel that you are locked into any one vendor, and you have to buy from them only. So you can, it's like a Lego block. You can change it at any time based upon your need. Okay, moving on. So 73% data teams using Data Lakehouse now, as per the latest survey. And IBM is one of the leading organization. We provide watsonx.data to save all your data. It's a hybrid platform. It's an open data lake house, so you can run your all your queries. You can have your dashboard ready. You can have your reports ready. You can query the data, and you can directly call your APIs. And the most important thing is this can pave the way for your all the AI needs or ML needs. So what's the next dot data is a data platform, and then you can feed this data into your all your AI systems. So what's the next dot data? It's a leading platform, a data lake house. There are some others too. Data Bricks also has some Lakehouse solution, and so some of the other companies. Oracle is also into this, but Watson Xor Data is the leading data provider for the Lakehouse needs and your unified storage architecture and query needs.